I'm really happy to be able to introduce Matt and Erica tonight. Just a little bit of background. Special interest groups are not a not a brand new thing to HAS. They were part of the early club when I first joined 20 something years ago. But over the last several years, the SIGs kind of became inactive. And one of the really neat things about the fact that we have a very active astrophotography SIG is that it seems like these days many new amateur astronomers are very interested to learn astrophotography, and this is one of the great ways that they can get energized and learn how to produce some astrophotos that they are proud of. Um, Matt and Erica Borledge moved from the Netherlands to Houston about 10 years ago. Both of them hold PhDs in mechanical engineering from Eindhoven University of Technology in the Netherlands. They currently are working in the Houston energy industry. Uh, they became amateur astronomers, and like a lot of others before them, they got very interested in astrophotography almost immediately. Their passion for astrophotography ignited 2 years ago, leading them to join HAS. They organized the astronomy outreach nights at Kleb Woods Nature Preserve, which Stephen mentioned earlier. And they'll be out there tomorrow evening, starting at 5:30 p.m. So if you would like to take advantage of an outreach event, and I'm sure they'd love to have you participate there. Um, Matt and Erica's interests include astrophotography as well as scientific imaging, with a focus on spectroscopy. Matt gave a really very wonderful talk about beginning spectroscopy for amateurs, and I know that's one of the things that has been part of their outreach events as well since then. Um, Matt recently became a member of the American Association for Variable Star Observers, and uh, uh, I think he ran into Walt Cooney at the AAVSO annual meeting not too long ago, in fact. Um, and that about a year ago, both Erica and Matt revitalized the astrophotography SIG, which, except for January, meets on the third Wednesday of every month. And with that, I'll turn the program over to Matt and Erica.
Thank you.
Thanks so much, Tom.
Thank you for the introduction. Let me see if I can share my screen.
No.
Should we have any concern that, that shoulder keeps going away? Is that
Oh yeah,
Yes.
I
okay?
tried various shirts already.
We tried several shirts, and he's not willing to put on a polka dot dress, so this is where we are.
Fantastic. I'm sorry.
It's good to know that you're not actually phasing in and out of the space-time.
Just the image, not the mindset.
Well, who knows?
All right. Well, I think that was a long, good introduction, and actually the rest of the talk will be all about our special interest group on astrophotography, and it's been almost a year that we started. We started in February, so the first anniversary is coming up. So we'll call this year one. And so what we're going to do is kind of look back on what we have done in the past year, how the community has developed and all the wonderful contributions. And then we're also going to look forward a little bit into next year, like all the fun things that we hope to see come to light. So, working. So we talked enough about ourselves. But indeed, tomorrow is the outreach in Klep Woods. Normally, it always has a star party at the end, but it will be cloudy, so the whole program will be inside, and we have an alternative program with rainbow paper and glue sticks and all of that. So it will be. You're still very welcome to come.
And you can learn about spectroscopy.
And you can learn about spectroscopy. And yes, indeed, we were very happy to get our first pin. That was an important moment. So we started actually astrophotography not too long ago, like say 1.5 years ago. And right after we started and we bought our first kit, we immediately joined the HAS. And I was initially to have access to the dark side, but then we found this wonderful group, and that actually was what kept us coming. So like I said, agenda for tonight, we're going to talk about astrophotography, and we call it 2.0 because a lot has changed in the years for many reasons. And so the astrophotography that we do today is maybe a little different from astrophotography back in the days. Then we're going to talk about the SIG, Special Interest Group, what we do and what has happened in the past year. And Matt put together a really nice gallery with all photos that came from the club members that they shared with us and that we really enjoyed exploring. So we're also going to do that tonight. And then as last thing, we're going to talk about what we're going to do next year, what our hopes and dreams are. So astrophotographer 2.0. So if you would see an image like this, maybe a couple of years ago, not too long ago, it would maybe be almost on the cover of a magazine. This is like a close-up detailed of the Heart Nebula, and you can see like wonderful details and depth and these very vibrant colors and all of these stars. And if you look at the stars, they all have their own little stories to tell. So there is so much detail in this picture. But it's wonderful that we now can take those pictures literally from our backyard, because we don't have like 10 billion what like a Hubble Space Telescope would cost. But with the equipment that we have today, with a fairly modest setup of maybe $2,000, that is roughly what you see here, you can take these pictures. And how we got there, we were kind of trying to summarize it, and we kind of said like, maybe there were like 3 big disruptors that got us here, right? So that really happened in the past years that made all of this possible. So that is what we'll talk first about, because then you can really appreciate those pictures that have come through the group. So the first, oops. It's not really advancing.
Yeah, so the first key pillar is the technology disruption. So if you ever looked into astrophotography, let's say like 10 years ago, or maybe 20 years ago, today is a very different world. And what basically happened is that first you got that rise of the CMOS, right? So these are the sensors, the chips that are now in all the phones and cameras, and they became very, very cheap, but they also became very, very sensitive. So technical terms around it is like the efficiency, the quantum efficiency of those CMOS sensors increased massively. If you take the camera that's now on the Takahashi on the dark side, that's an old-fashioned CCD camera. It takes a long while until you can get a good exposure of, let's say, a narrow band like H alpha. But the CMOS sensor is way, way faster, because the quantum efficiency is like almost 90%. Versus 30% or so for CCD. So there was this point in 2020 where CMOS really overtook CCD in the amateur astronomy community. So now it is relatively cheap, affordable to have very low read noise CMOS cameras. So that's a major game changer for us. So the second level is very recently, and it started a little bit with the ASR from ZWO, but now you also have alternatives. The whole software element became much easier, and it almost feels like cheating, right? It's a small box that you put on your telescope. You plug in the equipment, and then with an iPad you can do your whole imaging session throughout the night. It will automatically do the meridian flip. It will become very, very easy. And this is a very robust way to set up your telescope, and you can just go to sleep and then next morning you wake up and you collect your pictures. So that really was a big breakthrough in 2023. What happened last year is the breakthrough with harmonic drives. And this absolutely changed the game for all the long exposures type of photography that we do. So harmonic drives, basically, they don't have a belt drive system, but they have a direct drive system. So in many cases, you don't need a heavy counterweight, and backlash is completely eliminated. So you get out of the box tracking that would otherwise require a lot of tuning, a lot of balancing of your rig. And in addition to that, these drives are very portable. So if you want to go out to an outreach, or you want to go to a dark side, and you don't want to carry all those weights and all that stuff, or you have back problems even, right? Then this kind of stuff is a game changer. And we'll talk about it a little bit later on, but it doesn't only affect making pretty pictures of the night sky, but you also see that other domains like photometry and spectroscopy now become nomadic, right? So you can literally pick up your kit and you can go to any place where it is dark enough, and you can do science projects, science imaging, whatnot. So these technology trends, they make astrophotography very, very different from what it was just a few years ago. So you see that honestly, it's getting much easier to do this hobby. It's getting much cheaper to do this hobby. And then the data quality that you get back is just phenomenally better. So that's like pillar number one. The second pillar that we wanted to mention is the social media disruption. So here are a couple of examples of people that have a YouTube channel. And these YouTube channels, they have a lot of followers, a lot of views. And they are always on the news, looking for the best way to explain new technologies. It's not just product reviews and trying to sell products, right? There are truly good tutorials out there with big communities out there. So here's a chart where I put some data to see the YouTube search trend for astrophotography. So you see some rise because of those new technologies coming in. A big jump after COVID when people were looking for new hobbies. But then, to comparison, I also plotted astrology, which has nothing to do with our hobby, but there's also a lot of interest into that. So that's like the second pillar that really changed astrophotography. Next one.
And these I would say these YouTube channels, they really are a very solid source of education. It's not entertainment. It's really they have very good educational value.
Yeah, I gotta add, they also have their own like Discord communities. So there are thousands of people that get together online. And because these images are nice to share, and you're proud of your work, you want to share what you did, there's a lot of incentive for people to explore and grow and learn together and give each other very constructive feedback. So behind those YouTube channels, you often have massive communities, international, connected with apps of people that are helping each other. And if you're starting off in this hobby, I would absolutely recommend to look into one of those channels and see like, okay, what really clicks with me, what kind of community resonates with me, because you will learn very, very fast. And that's also honestly a whole crowd that's coming into this hobby of astronomy, very similar to what we did as we just started to make some pictures from our backyard, and didn't know a lot about astronomy yet, but we're initially just interested to make a nice picture. And the last pillar is the software disruption that really happens. So on the right hand side, you see like animation of an image that is stacking. The signal to noise ratio is just massively improved because of stacking. So you can go after very faint objects like nebula and like very faint stars with stacking. And you collect a lot of exposures with relatively small aperture rigs. And then after stacking, you get that image like in the middle. And then after some processing, some stretching and so forth, you can really get the best signal out of your data. So that's the reload. So what we see happening now is that originally you had PixInsight. That was the paid for package, which was very complicated to use. Very, very nice. You can do a lot of stuff with PixInsight, but it was very user unfriendly. Now PixInsight is now getting more and more work by amateurs, people that contribute to making scripts for PixInsight. So you have new plugins that make life really, really easy. It almost feels like cheating now. So that's happening on one side. And then on the other side, you see free software, so open source software. Cyril is now very famous. It's developed by a couple of French people. It's English language, of course. But Cyril takes care of stacking, very efficient. And then you have a lot of the processing as well that you can do in Cyril. And there's a new version coming out, like a next iteration of the development in a couple of months. And it is really approaching the usability of and the power of PixInsight. So generally we see we see a little bit of a battle coming up, that at one side PixInsight is getting easier to use, and at the other side you have the free software that is getting better and better. So in the end, the data that you are able to collect will be easier to process. So also this last step is just massively changed over the last year even. The last thing I wouldn't call really like a big pillar, but there's definitely something happening in the smart telescope world. So in February, we had a dedicated session that you can still find on YouTube, where people from our community, like HAS, described how they were using smart telescopes. So if you're interested in smart telescopes, I would definitely look that up. We've not seen a lot of people spilling over from smart telescopes into the astronomy, astrophotography group yet. That may come at a certain point, we don't know. There's also a lot of stuff developing in these smart telescopes. So right now they're really targeting very low cost, small portable units that really compromise on performance, but gives you a great first shot picture of a nebula. But there are also some other models now coming out that are a little bit more advanced, they're more expensive. So maybe at the end, smart telescopes will also feed into astrophotography. We haven't seen it yet, but of course, it's one of those things that really took off last year as well. So those are kind of the new things. If you didn't know anything about astrophotography, or maybe you gave up like 10 years ago, 15 years ago, try again. It's so easy that it is a very different part of astronomy today. And because of the power and the sensitivity and all the wavelengths that you can see with CMOS sensors, all the areas that you can explore, definitely recommend to have a look at it again. So yeah.
Yeah. So that was basically Astrophotography 2.0. So the next part, it will be really about the special interest group and the things that we do. So like I said, we started in, here it says February 28th, and that was basically when we had our first of the series of the monthly webinars that we do, so like every fourth Wednesday of the month. And so this was the first slide that we showed at that point, and we were a little nervous if actually anybody would show up, or it would just us two be in the meeting. And initially it seemed to be that it would just us two in the meeting, but we just realized that we shared the wrong link and we had some technical problems. But after some emailing and some text messages, we actually had a crowd together, and it turned out to be really fun. So before we started the special interest group, we spoke to some people and kind of got some idea of what people's expectation would be and what they would be interested in. And in one of those discussions, having a target of the month came up. So basically one deep space object that we kind of present as a challenge for that month. We picked the target such that they are actually visible for a good section of the night during that month. And when we started this in February, it was galaxy season, so it was not really the easiest month to start, but it did take off, and we still have the target of the month, and we'll show a lot of that what came from this. But yeah, this was slide 1. So each webinar we actually have the same agenda, and that seems very boring, but it also gives a lot of structure. So our standing agenda kind of always looks like this. So we first introduce the new members, and we still have every time like a few new members. Sometimes very seasoned photographers that we can learn a lot from, and sometimes really a novice that just got their first equipment set together. And then what is taking the longest part during these meetings is actually a round table where we go through a slide deck which contains all the all the targets of the month that have been submitted by the members. And sometimes they get emailed to us directly and we can put them in the slide deck. But I should credit Matt for it. He always goes onto Facebook and onto Discord to find all the postings, and with that he always writes down some of the technical details and conditions that these pictures were taken in. So it's a lot of fun to go through that, and we'll do that a little bit later today. So then there's open forum. Believe it or not, but we have a lot of war stories. We have all the things from tripping over wires, sprinkler systems that go on in the middle of the night, packing everything except for bug spray, and things worse, not to be mentioned here. So after that, we try to keep up with new products that come out, like software and new tricks to process your data, and then we always reveal the next target of the month, and that's the closure. So this is kind of an overview of the targets that we've done so far. So we started in February, so our first target of the month was for March. You can see we tried to get to some variation in broadband and narrow band filters. Narrow band filters, when you're in a more light polluted area, you have a better shot of actually getting something. Also, like I said, we try to pick something appropriate for that time of the year. You know, some people have a good north sky, some have a better south sky, so it's a little bit of mix that we try to put together, but it's always received with great enthusiasm, and sometimes it's like, ooh, this is a challenging one. When we introduced the Pleiades, it was interesting. So here we went back and for each of the months calculated how much pictures actually were submitted. So you can see for March there were 4 pictures, 6 pictures, 4 pictures, and from then on we have really seen a steady uptick. So when you have like 14 pictures to discuss in a meeting and to go over, it's really fun to see the variety and the creativity and the challenges that people have encountered and overcome. And it's always, you learn a lot. We've seen many times that after the meeting and discussing it, people reprocess the pictures again with new insights and new things to do. So here is kind of a blurb of many of the pictures that were sent in. You want to take over from here?
Yeah, sure. So we'll pick out a couple and then kind of go through them and share a little bit how we also talk about those pictures in the meeting, so you kind of get a flavor for that. But you can always see from this shot that even for the same target, people have a very different take on the target. So it not only like the color combination that they use for the different emission gases like sulfur and H alpha and oxygen, but also the composition or if the framing, those kind of things. So there's a lot of variation that you see, and it's actually really remarkable. Last time we were discussing the Pleiades, like literally all 14 submissions were very, very different. And it's not so much that sometimes it's like magazine quality picture, and it's amazing, and it has a lot of hours of exposure in the very dark side. And sometimes the art is also the location and the equipment of how that data is acquired, and that's something that we all really are interested in as well. So let's go to a couple of pictures, right? So see, maybe one more click. Yeah, so this one is by Kenrick Katter. So this was actually made in a very, very dark site near Fredericksburg. And then we typically list the equipment and the exposure time on it like that. What is amazing about Kenrick's picture here is that it is very broadband, so there's almost no filtering. So you see a lot of different dust clouds and a lot of different star colors there, as well as the H alpha emissions and sulfur emissions from the Heart and Soul Nebula, right? So this is Heart and Soul. So this is absolutely like a top shelf picture from this. You could literally print this into a magazine. If you go to the next one, the same kind of excitement is the picture that we have here. This is from Bill Conkle. This was made in a Bortle 9 zone, like in the middle of Houston, with a nearly full moon, with modest equipment. And this is a broadband picture, right? So this is the Pleiades, of course. So the spectrum of this is broadband. So you cannot use narrowband filters to reject light pollution, right? So in order to make a picture like this, Bill took 11 hours to collect those photons and to improve the signal to noise ratio. And then he used a completely free open source software to actually get all the details out as you see it here. So this is a picture that in our meeting we thought was spectacular in its achievement of getting to this stage. And you can see all the different colors of the nebulosity there. But from a Bortle 9, that is a absolute top achievement. So just to kind of give you a flavor of that. But more on the Pleiades, this was a really cool thing by Gary Ray. So Gary recognized that the stars in Pleiades, they're mostly very young stars, like B-class stars. And when you do the processing in PixInsight, you kind of have to figure out sort of like a white balance, right? So a color correction that you apply to that field. It's called spectrophotometric color calibration. And usually people take kind of the default as an average spiral galaxy. And that basically means that the spectrum of your calibration is similar to our sun, right? So it's mostly like G-class stars. So Gary figured out like, well, that's not right because these stars are B-type stars. So he used the B stars to calibrate the image. And because he did that, he was able to amplify a lot more nebulosity around the Pleiades Nebula. And here you see where at a certain level with processing, this is not something that you just automate and click a couple of buttons. This is really where you have to get connected with the object, the target that you're trying to image, really understand what's going on, and using that astronomical stellar class knowledge, then you can get to the next level in getting the detail out. So we're all really impressed by that insight. So if you go to the next one, it's actually a bigger image by Gary, and one more click, then you see like all the data there, like how he did that, so how he really collected that. And this is a 2-hour image from the dark side. So can you just imagine? It's just incredible stuff. So we have more cool stuff because this is like literally a candy store for us, right? Every part of the night sky is a whole new piece of Astro stuff. So let's go to the next one. So this is by John. So John Banner, this is from his backyard. And the cool thing here is that he played with the different emissions from the North American nebula. So basically oxygen and H alpha, and then played with the different color palettes that you can make, right? So H alpha is really hard to see visually. So you have like the Hubble palette and different palettes of how people give colors to the different emissions. And here it shows, these are good examples of just black and white H alpha. So that's mono in only the wavelight of H alpha. And on the far right hand side, that's a combination where you have, instead of RGB, you have H alpha, oxygen, and then you get that side. And then there's a kind of a new kind of algorithm that we're all very excited about. That's the Fornex palette, and that's in the middle. So he was really using the different wavelengths of the light to see more detail and enhance certain features of the North America nebula. So also very interesting piece of work. So next one more click. Yeah. So this one is by Philippe Mendes. So he really wanted to image the bow shock around this Wolf-Rayet star, and that is near Cygnus, I guess, right? So it's the Crescent Nebula nearby. So you see the kind of blue kind of wave thing. So these are the shock waves literally coming from exploding Wolf-Rayet star. And we were figuring out in the meeting how you can get the data, this blue data out, the oxygen out from the data that he already shot. So we were figuring out like what processing steps do you need to take to enhance just that bow shock. And then you can see there below, that's I think it's the yellowish with a blue star. I'm not really sure. One of the stars, that is the Wolf-Rayet star that's actually causing that bow shock. So this was also a point where we're really trying to understand, like, okay, what's going on here, and how can you use everything of the signal that you captured to get the maximum out of your picture. So just to give you a flavor, right? So this goes all the way from making something nice and you could put it in a wall to getting better and closer to actually exploring those pieces of the universe, what's going on there. I think the week after I took out my spectroscope and I shot the spectrum of the Wolf-Rayet star because we were just talking about it. It is all now super accessible for everybody, even from the backyard or from the dark side. So yeah, to kind of give you a flavor.
Yeah.
Yep.
It's you can see we go from really nice pictures, but in order to make those pictures, you have to understand the subject. So you get to the astrophysics pretty fast, and it just draws you in. It's wonderful. So this was looking back for what we have done in the past year, in the past 11 months. So now in the next slide, we're going to see like what's next. You know, we have a whole brand new year right in front of us, and we're excited for it. So one thing that we attempted 2 times is to actually, because we have done all of these Zoom meetings, and there was really great desire to just hang out, you know, to meet each other in person, have a nice dinner at a restaurant, go to the dark side, and capture a lot of that oxygen that is hard to get from our backyard. So we wanted to have this in-person meeting. We tried 2 times, but every time clouds you know, came in and we had to cancel. So the last time, actually, this set of November 3rd, we decided, well, we're not going to cancel. We're just going for an alternative. So what we did, we stayed in Houston and we met at the Lazy Dog restaurant, and with a group of people that most of them only met online before. We had a really fun evening, and had to order extra dessert because we still had very good conversations for on astrophotography. So that doesn't mean that we are not going to do a dark side night. We'll just try it again. We just keep on trying. But what I wanted to say is that meeting in person is really some of the things that we want to aim for in the next year. So we talked about the webinars. We talked about the in-person gatherings and just hanging out and really seeing each other's equipment, right? So there's even with all of this talking, sometimes just seeing how somebody has done their cable management and you know, little tricks of transporting some of the sensitive equipment. It's or just sharing cables that you forgot to bring. It's always a good thing. So one thing that we also did in this year, but we put it for next year because it has not been so active yet, is we were granted access to a portion of the share drive from the HAS, and it's massive. And one of the things that you have with astrophotography is lots of data, lots of pictures, lots of images, and we'd like to share and keep some of those for educational purposes. And sometimes you don't have new material to process, so it's nice to share. We also want to set up group projects that we can work on. So this is something that I know will be a great tool in the next year. And if you're interested, we can grant you access, and we'll fill this up. It's a big Google Drive, so it's very easy to work with.
So basically, what we store there are the stacked images. So any of our club members that has already stacked and calibrated their images, they can store that stacked image there with a little bit of documentation, and then they could basically share it with everybody within HAS. And that's a big deal, because when you're just starting off in this hobby, half of it is trying to figure out how you process the data. So if you're still trying to figure out like how do I get good data, then you can only get started with that second piece of it. So that's a big deal. And then also, as you process your own images, sometimes it's cool to ask somebody else to do it for you, and then compare, and so see what they can get out of the data, because it's something that always evolves with new tools and all that kind of stuff. So that's a really cool thing. And then what's coming up next year is that we can also go after like a joint project together, or maybe even we talk about it a little bit later, maybe do some science stuff there as well. So thanks to Joe Kalev for setting it up.
Thank you.
We have terabytes of room for this to further grow. So that's pretty cool.
Yep. So one thing that we talked about, and it's still a question mark, so we still have to make the final decision if we're going to put in the work. But it's to basically to create a novice program specifically for astrophotography. So really a kind of a small scale boot camp to just get you started. So it's a program we would be like a program for absolute kind of beginners. And because one of the things is once you get started, you can pack on more, but you just need to get from start to finish, from capturing your first light and processing your first light, and you just have to get through that workflow 1 or 2 times with some guidance, and then most of the time, you know, you've gained enough momentum to start building on that. So so one of the things is like, if you're interested in this, then let us know. If we hear enough motivation, then yes, then we're just going to do it. So that's basically the big blocks that we envision for this year. So if you have any other ideas, then please let us know. So there's one last bit that we wanted to discuss, and it's something that Matt already kind of hinted towards. Once you start taking those pictures of the night sky, you start having those conversations. What am I actually looking at? I still remember the first time we came to the dark side, and Steve Goldberg welcomed us. He was there as well, and we just stood there with our camera. This is like 1.5 years ago, and we said like, which direction do we point it? So we know like absolutely nothing about the night sky, and I'm not saying that we're expert right now, but we're willing to learn. And because of those taking those pictures, you're drawn in, and you're becoming more and more curious. So I don't know if we can get really to doing science, but kind of the experimentation and driving our curiosity, I think that is really something fun to share. And with the setup that we have, you know, that with those nice cameras and the really nice lenses or mirrors, we can put some really interesting things together. And I'll
so
here.
So a couple of things that always were very hard and are now extremely, like, ridiculously easy is the following, right? So spectroscopy, you know, the YouTube video that we made for the meeting like a couple of months ago, beginning backyard spectroscopy on our own HAS YouTube channel. I walk you through that. So basically, you use a astrophotography kit, a wide field refractor, and you can above there you see like the basically the methane bands from Neptune. Right, so shot from our backyard. So that's what you can do. You can take the same kind of equipment, and it doesn't take a lot of extra work, and you can pursue a spectra of stars, or in this case a planet. So that's really within reach, right? Then the next one is variable star photometry, right? So you heard us talking about the AVSO. There's also a YouTube there on our channel from the HAS that basically some of our members are sharing what they're doing, you know, with science, variable star photometry. Above there, you see a plot from Tycho Bohr from Walt Cooney, right? And it's basically the same principle. So if you have an astrophotography rig, you could do this. it's just like black and white pictures or even color pictures, and you can study variable stars. It's one of the coolest things. And then the next one, right? Also exoplanets, right? A little bit related to photometry. So you can study exoplanet transits. So this is a YouTube video, not from HAS, but from somebody else on YouTube. And basically, he's also using the same data acquisition workflow as for astrophotography, same equipment, to do exoplanet transits. So there was a video, a talk for HAS where a lady was talking about the atmosphere of studying for exoplanets, right, with the James Webb Telescope. But you can study the transits and verify the period time for exoplanets with your own kit. So and actually, all those things, they kind of look complicated from the outside, but it's actually way simpler than making a really good picture of a nebula with your astrophotography rig. So all those things, they are within reach. And if you're interested in that, then maybe that's something that we could explore next year as well together.
Mhm. All right, so this brings us to our final slide, and all we have to kind of add to this is like, if you're interested, let us know, join us, like on our monthly Zoom meetings, or you know, just continue the conversation on Discord, Facebook, and if we ever get again to the dark side with clear skies, then we'll post that everywhere. So. Thank you. This is the end of our slide deck.
All
We
right.
don't have
Thank
this is
you.
time for
Thank you
questions
very
slide, but
much.
you kind of implied that.
Yeah, exactly.
Thank
So let us
you
know what
very
you
much,
think.
Matt and Erica. Do we have, does anyone have any questions for them about any of this? Feel free to, let's see
Oh.
if we have any on the chat.
So I have one, Stephen. Just
All right, done.
okay. Obviously, things have built up over the last 11 months. What specific area would you say the most energy has been generated in?
Oh, so I think we were really surprised by the enthusiasm of the people picking up the target of the month, as well as the discussions that we have on that together. So it's very support. It's a lot of support between members, helping them out with stuff, and not just like the small equipment, but also how you get like more out of your image. It's been it's an easy job for us. So, but yeah, there's a lot of enthusiasm came because of the target of the month.
Yeah, and it just makes you curious once you have pictures to talk about, and then everybody has their own way of looking at it, and then sharing those perspectives. That is, I think, that's really, I think, a very wonderful part.
Yeah, it's almost like everybody is exploring the universe in its own kind of unique way, and kind of going from making a pretty picture into really connecting with what's going on there. That's something that I've seen like over the last couple of months really taking off.
Mhm.
Yeah.
Walt, you have your hand up.
Yeah. Hey, I just wanted to ask, some of the pictures showed from local HAS folks were just really kind of unbelievable, APOD capable pictures. Uh, it's a little hard to imagine being able to do something like that. What about regular people who do regular shots?
I think it's a really good question. So I think there are two things going on there. So one is that the software is getting very easy to make like an 80% nice picture. So that is really it's much easier on that end. And I think what I've also seen is that people are, because they are now getting together into a community, they are learning very fast. So we've had people that really started off also with modest equipment, modest data, and then they really accelerate. So one thing that I'm personally a little bit worried about is that sometimes it may go fast and it will be harder for people to get in. But I don't think that's really true, because in the end it's all about how people are helping each other out, and the atmosphere is still very open and very supportive for people that are new in the group. So don't hold back. Just join in or listen in.
I think that's
yeah.
also the reason why we were thinking about starting this novice program or a refresher program, because of those three things, like the new software, the new technologies and control, and then access to information, it has become really significantly easier. And I was laughing a little bit because I was like reading in the chat. I think we have actually people who want to come back and to reconsider doing imaging. It is yeah, it is it you think it's very complicated, but at the end of the day, it's just taking a picture.
Yeah.
So
And I will say too, thanks for y'all's leadership, and the enthusiasm. Very infectious.
Pleasure.
If you wouldn't mind my making a quick comment
Yeah.
as well, because I've been pretty continuously at this for 20 years, and I have to absolutely amplify your approach that says it's gotten much easier in the last 4 years or so. That's absolutely true. The second thing is that that when I first got started, there was a lot of emphasis on it needs to look like like what it is. It's a scientific image, right? Blah blah blah. There was a lot of resistance to anybody using any artistic insight into how they wanted to display their process their image to display it differently. That's pretty much out the window. There's still people out there that are kind of going like that, but the artistic quality of a lot of these images is just tremendously better than it was 10 years ago, because there's been more people working at that. So
Yeah, great points. Yeah.
anyway, that's the part I find most edifying, because it's like, I finally get to do some stuff that the software is easier to use, and I like doing things a little bit more artistically, and I'm able to achieve that a lot better than I could even 3 or 4 years ago.
Absolutely. Just saw Glenn's Cornier's comment there. So if right now you are in the position where you're just starting in astronomy or astrophotography, and maybe you have some like beginner questions or something, don't wait for the novice program. Just join the meetings that we have, like the monthly webinar, because we always have this open forum for questions and things, right? And then we can help you out immediately. So don't delay starting your adventure until we may or may not do a boot camp. Just join us, and we can all figure it out together. And we really go over things from, hey, I get this weird error in my mount, or whenever I do a meridian flip, I hear a loud crack. So there are all these different things that are going on. So just join. Don't wait. Just come join us.
there's also a question: are there smart binoculars available yet?
Oh yeah, I heard about those. I've not been seeing those binoculars taking pictures, but there's definitely like a Kickstarter project out there does some kind of plate solving. So it's like tells you what you see through the binoculars. Yeah, that's maybe the EAA SIG can dig that up a little bit. But, yeah. Okay, all right. Yeah.
Well, thank you.
There's more questions or anything that would help you with?
Anybody else?
Okay. Alrighty. Okay.
All right.
Well,
Thank you very
thanks so
much.
much.
Well, thank you, Matt and Erica. Let me pull up my final slide right quick here. And so our next meeting will be, as Bill asked about before, our next meeting, the novice meeting will be on Thursday, January the 2nd at 7 p.m. Our next general meeting will be the following evening, Friday, January the 3rd. You can visit our website, astronomyhouston.org, for all the details of that meeting and everything else that's going on in the club. You can also contact us on all the social media that you see here on the screen: Facebook, X, Instagram, YouTube, or just email us at info@astronomyhouston.org. If there's any info about what's going on in the club you feel like you're missing and you need to know, just hit up the info email. We can help you out there. So on behalf of us all, thank you for being here tonight, and I wish all of you clear skies and a pleasant evening.